Okay, here we go. Geometry 1.5 angle pairs. We're going to be starting on the second page of notes today, looking at diagrams and what we can assume to be true and what we cannot. All right, let's start with what we know is true, okay, as indicated by this diagram here. We've got these two lines here, and those indicate that segment TW is congruent with segment WV. Okay? So it might be tempting to say, man, if TW and WV are congruent, it sure looks like PW and WQ are congruent. Okay? And even if you got a ruler out and you matched them up and they certainly look pretty close, we cannot assume that. Okay? So we cannot assume that segment lengths are congruent. Okay, we cannot assume segment lengths. And we also cannot say, man, these certainly look like perfectly perpendicular lines. I'm going to say that these are right angles. No, we cannot do that. Even if you get your protractor out and you measure that angle and it certainly looks exactly 90, we cannot assume right angles. Okay, this is the not section. We cannot do that, okay? What we can do, what is okay to assume, is vertical angles. Okay, so if we look at angle TWQ here, all right, we might not know the exact measure of this angle, even though it certainly looks pretty close to 90, but we don't know its exact. But I do know that it has to be the same measure as VWP because they are vertical angles, and we can assume vertical angles. Okay, so let's write that out. Angle PWV is congruent to angle TWQ or QWT. Again, the order doesn't really matter. It just, you have to have the W in the middle. Okay? All right, is that the only set of vertical angles here? No, we also have this angle here. Oops, went away. This angle here, TWP, has to be congruent with VWQ. All right, let's write that out. Angle P has to be congruent to angle VWQ. Okay? All right, moving on. A linear pair is a pair of adjacent angles whose non-common sides are a straight angle. And we know a straight angle is just a straight line, right? So let's write a picture of that. The key here is a linear pair actually has to be adjacent angles, okay? So they have to be touching. Okay, so if I have angle 1 and angle 2, those are going to be a linear pair because they together make a line. All right, that's pretty easy. All right, and we have a postulate, and this postulate is pretty common sense. It just kind of is pretty intuitive here. So a linear pair postulate says if two angles form a linear pair, then they are supplementary. Okay, or in other words, they add up to 180 degrees, right? So if we have, we'll do the same, a very similar drawing to the last one. The one above, we have 1 and 2. And so what we're saying here is that angle 1 plus angle 2 have to equal 180 degrees. All right, so that's pretty basic, but we're going to be using this to solve equations. So let's take a look at some examples of that. All right, the first one here, I'm going to zoom way in here. First one here. Wow, we got to find the measure of all these angles. Let's start with the easy thing. We got this box here, EOA. It's got that box, so we know that EOA is 90 degrees. All right. And let's see, what else can we deduce here? If this is 90 degrees, then this side here has to be 90 degrees as well. And now that's not assuming right angles. If this is 90 degrees and this is a straight line, this has to be 90 degrees, right? So if this part here is 60, then this part COD has to be 30 degrees. Okay? All right. This is probably the trickiest one here, so I'm going to go with this one next. So we've got vertical angles here, right? This angle here and this angle here. AOB also has to equal 30 degrees. All right, and the last one here is probably easiest to look at, going from DOB, right? From here to here, that's two angles that are linear pairs. So this whole thing has to be 180 degrees, right? And if this is 130, that means that angle BOC has to equal 150 degrees. Okay? All right, let's move on here. Okay, now we're getting a little bit tricky here. We've got this angle is a little hard to see. That is x minus 33, and then there's a little degree sign up there. We know that these two angles form a linear pair, right? From here to here is 180 degrees, right? And this one's 142. This is x minus 33. So all we need to do here is say x minus 33 plus 142 has to add up to equal 180 degrees. All right, so then we go ahead and we combine like terms and we just solve this equation. This should be a review for us. Combine these like terms, we get x plus 109 is equal to 180. And we subtract 109 on both sides. And we get x is equal to 71. So x is equal to 71 degrees. And this should make sense. This should go back to the original, right? If I plug this back in, if x is 71, and I do 71 minus 33, I get 38, right? So this part here would be 38, and we know this angle is 142. Does 142 plus 38 equal 180? It sure does. So it checks out. I can check my answer on these, and I can be certain I got the right answer. All right, let's move on here. All right, now we got a problem with a right angle. Okay, so it's just key to remember your angles here. So this right angle is 90 degrees. And I know that this angle here plus this angle make up this right angle. So all I have to do here is say x plus 6, or sorry, 6x plus 3 plus 3x plus 6. These two angles have to add up to equal 90, so I set them up equal to 90, and then I just solve for x, right? Combine like terms, we got our x's, so we got 6x's there, 3x's here, I got 9x's, 3 plus 6, we got 9, is equal to 90, subtract 9 on both sides, and I'm left with 9x is equal to 81. And last, I just divide by 9 on both sides, and I'm left with x is equal to 9. All right. Moving on here. Okay, now this one we've got, looks like we're dealing with a circle here. Okay, so it's good to recognize that if I were to close this, Oh, that's bad. If I were to close this loop here, ooh, that forms a circle, right? And a circle is 100, or sorry, a circle is 360 degrees, right? So if we start with that, if that whole thing is 360, I'm going to set that on one side of the equal sign, and I know that 245 plus 32 plus x minus 39 all has to equal 360. So when I do that, now I just have a multi-step equation that I can solve for x on. So 245 plus 32 plus x minus 39, and I just combine my like terms here. 245 plus 32 minus 39 equals 238, plus x is equal to 360, and now I just subtract 238 on both sides, and I'm left with x is equal to 122. Okay, I'm going to actually, because I think I got a little bit of time here, I'm going to go ahead and show you a different way to solve this. Maybe you prefer this method over the other. So I'm going to erase this. All right. So again, we know that this whole circle is 360 degrees, right? So that means that this portion here is the remainder of 360 minus 245. Okay, so if I do that, if I subtract that out, I get 115. Okay, so I'm just gonna kind of like stretch this out. So basically from here to here, right, is 115 degrees. All right, so now it's a little bit smaller numbers to deal with. You got 32, this angle here, plus this angle here, has to equal this bigger angle, right? So if we do 32 plus x minus 39 is equal to 115, combine these like terms, and I'm going to get x minus 7, right? So 32 minus 39 is negative 7, so I'm just going to call that x minus 7 is equal to 115. Then I just add 7 on both sides, and I get x is equal to 122, just like I did before. So both ways work, whichever your preference. If you like dealing with 360, if you like dealing with a little bit smaller numbers, whichever one works for you is fine with me. All right, you guys are done with the notes for this week. So go ahead and give these practice problems a shot. If you need help, check out my practice problem video. All right, good luck.